Hello everyone, glad to see you. Today we're going to talk about profile of surface and composite feature control frame. Let's start. At the top left we have three planes A, B and third one. Plane B is perpendicular to A and the third one is perpendicular to A and B. At the top right we are going to change all these perpendicularity symbol to surface profile symbol, as you can see here. These two figures, they have the same meanings. We change the perpendicularity to profile of the symbol. Whenever we have perpendicularity, it means we are going to have two perpendicular planes and the distance between these two perpendicular planes to be 0.2. And here we have surface profile symbol. It means we are going to have two parallel surfaces with the same shape as the original one. The original one was perpendicular to plane A. It means these two planes will be perpendicular to A. Somehow we are going to check the orientation of that. It is exactly the same as perpendicularity because they are perpendicular at the beginning. And by changing this perpendicularity to profile of a surface, we are going to satisfy the same condition. Let's go to second example here. It is the same as the first one, but we have the fourth plane here. It should be parallel to plane B with a t0 of 0.1. And again here in the middle, we can see if I'm going to change this perpendicular to surface profile symbol and this parallel condition again to surface profile symbol, it means I'm going to satisfy the same condition. In this situation, I'm going to have two surfaces should follow the original shape, and the gap between these two should be 0.1. And whenever the first one is parallel to A and perpendicular to third plane, it means I'm going to satisfy the same condition. I'm going to control the orientation and the form, and the t is 0.1. In the middle, we can see this length is 22 plus minus 0.15. We can see these two boundaries can move in that interval. Let's go for last example in this slide. We can see it is the same as second example, but instead of having tz for the size of 22, the basic dimension is used. This 22 is in the box. What is going on here? It means we are going to use this tz 0.1 for this basic dimension. Somehow we are going to control the location as well. We have this surface profile symbol. We are going to control the form and orientation. We have reference plane B, and we have this basic dimension here. That's why we are going to control the location as well in this example. In this slide, we have this composite FCF here, and TZ for this surface is 0.1, and we don't have any reference plane here. It is 0.6. We have reference plane ABC. It means we are going to have these two boundaries. 0.6 is here, and 0.1 is going to control this profile, and this profile can move and translate in that interval 0.6, as we can see at the bottom left. At the bottom right, again, it is the same. This wavy profile can move and rotate in the interval of 0.6. What is the meaning of this triangle here? It is dynamic modifier. By having this triangle or dynamic modifier, we can have normal expansion, contraction away from through profile. As we can see at the bottom left, we have expansion. At the bottom right, we can see it has contraction, and it is because of this dynamic modifier. Let's see this example. We have this profile here. We are going to have two TZ. One of them is 0.4, and we have dynamic modifier. Here we don't have any reference plane, but at the top we can see we have reference planes ABC and TZ equal to 2. The same as before, we are going to have this boundaries 0.4 for the profile, and this profile can move and rotate in the interval of 2 here. But consider the case when we don't have this dynamic modifier, when we don't have triangle here. What is going on? It means we are going to make this TZ 0.4 around the basic dimension, as it is shown with these red boundaries. It is around through, not through, around the basic dimension, and this TZ, these red boundaries can move and rotate in the TZ equal to 2. That is the advantage of, let's say, dynamic modifier. We can have expansion or contraction. Let's see this example. Here it is the same as before, but at the bottom we can see we have TZ 0.4 and 2, but at the bottom when it is 0.4 we have these two reference plane A and B. As we have learned so far, when we have the reference plane for the profile of surface, somehow we are going to control the orientation of that. And here, by comparing these two figures at the right hand side, we can see when we don't have this AB here, it is free to rotate. Sorry. It is free to rotate. But at the bottom, we can see we have reference plane A and B. It means it is not free to rotate. It is free to rotate in this interval when TZ is 0.4. Yeah. Thank you for today. Now I would like to close this session. I hope you enjoy it. See you next time. Have a nice day.